Now we'll study an important phenomenon in nuclear physics, that is the effect of nuclear size on its stability. We know well that inside a nucleus all protons repel each other by electrostatic force. So if we talk about a proton on the surface of a nucleus and say if there are some more protons, then each proton repel this proton due to the electrostatic force. So net force it will experience an outward direction. So here we can write as electrostatic force is a long range force all protons in nucleus repel each other, no matter wherever other protons are located. But when we talk about the attractive force on every proton, that attractive force will be mainly because of the neutrons in the surrounding of the proton. So if we talk about a neutron which is located far away from this proton, as a nuclear force is a short range force, and if the size of nucleus is large, the neutrons which are far away from this proton will not contribute in any attractive force on this proton. So here we can write as nuclear force is a short range force. Here we can write only neighboring neutrons contribute in nuclear attraction for stability, because we have discussed that a nucleus will be stable only when the attractive force on this proton due to the neighboring nucleons will balance the electrostatic repulsion. So all those neutrons which are very close to the proton will only contribute in the nuclear attraction on this proton. So for every proton, if the phenomena is same, every proton will require more number of neutrons in the surrounding, because the strength of nuclear force is relatively less compared to electrostatic force. So based on this, we can just state that in almost all stable nuclei, number of neutrons must be greater than number of protons. Here we can also add one thing: if size is large, or we can talk about heavy nuclei, because we have studied that if the nuclear mass is high, its volume is also relatively large compared to lower weight nuclei, and the size will also be large. So we can say for large size nuclei, number of neutrons required will be more than number of protons, because in this situation we can say every proton require more number of neutron in its surrounding for balancing the overall electrostatic force acting on it. Electrostatic force will be due to all the protons in the nuclei, but nuclear force is only due to some neighboring neutrons, as the nuclear force due to the neutrons which are far away from a proton, even within the nucleus, the nuclear force is very small.